Assalamualaikum and hi, my name is ARISSA binti ANUAR from 4 Unku AMMAR. Together with my group mates which are AMMAR AFIQ, AZIM, IRFAN, KHAIRUNNAS, DIENA and AESYAH, guided by Sir SYAWAL, our chemistry teacher. We would like to lead you into our experiment about determining the empirical formula of magnesium oxide and also copper dioxide. First of all, let me explain a little bit about empirical formula. Empirical formula is obtained by the analysis of percentage composition of a substance. This is done by determining the simplest whole number ratio of atoms of each element that combines through an experiment. Okay, so I hope all of you already understand this simple definition. So let's get into our first activity, which is determining the empirical formula of magnesium oxide. To determine the empirical formula of magnesium oxide, materials that we need are 10 cm magnesium ribbon and also sandpaper. Meanwhile, for the apparatus, we need 6 apparatus including crucible with lid, tongs, Bunsen burner, tripod stand, pipe clay triangle, and electronic balance. Procedure of this activity are not really complicated. We can simply start it off by weighing and record the mass of a crucible together with its lid. Then, wrap 10 cm magnesium ribbon with a sandpaper until it becomes shiny. We have to wrap the magnesium ribbon with a sandpaper before using it to secrete oxide layer on the surface of magnesium ribbon. Then, coil the magnesium ribbon and put it in the crucible. Weigh and record the mass of the crucible together with its lid and the coil of magnesium ribbon. After that, set up the apparatus as shown here. First, heat the crucible without its lid. When magnesium ribbon starts to burn, close the crucible with its lid. This step is to avoid white fume, which is the magnesium oxide, from diffusing out. Using a pair of tongs, lift the lid slightly from time to time and quickly place it back. This is to allow air to enter the crucible so that the oxygen in air can react to magnesium ribbon. When the burning of magnesium ribbon is complete, take off the lid and heat the crucible with high temperature for 1 to 2 minutes. Then, put back the lid of the crucible and allow it to cool to room temperature. Weigh the mass of crucible together with its lid and its contents again. Repeat the heating, cooling, and weighing process until a constant mass is obtained to ensure the reaction occurs truly. After this experiment is done, record the constant mass as in the table shown. Thus, the masses of magnesium and oxygen that combine are determined. We also have determined the empirical formula of magnesium oxide. Here's a quick simple question that you might probably get asked. What will happen if the white fumes, which we already identified them as magnesium oxide, are released into the environment? The answer is the results will not be accurate and it can affect the determined empirical formula. Moving on to the next experiment, which is to determine the empirical formula of copper dioxide. For this experiment, we need to provide water, copper dioxide, zinc granules, 1.0 mol per decimeter cube hydrochloric acid, wooden splinter, and cotton buds. The apparatus needed are boiling tube, rubber stopper, rubber tube, 12 cm glass tube, 10 cm glass tube, spirit lamp, retort stand with clamp, wooden block, electronic balance, and spatula. The procedure is, firstly, we need to weigh the mass of 12 cm glass tube using an electronic balance and record its mass. Second, we have to put some copper dioxide powder into the glass tube. Make sure to use the wooden splinter to move copper dioxide powder to the middle of the glass tube. Then, weigh the mass of the glass tube together with its content and record the mass. After that, Fill 2/3 of the boiling tube with water. Then close the boiling tube with a rubber stopper that has a 12 cm glass tube. And clamp the boiling tube onto the retort stand. Next, insert a few zinc granules into another boiling tube. Add 1.0 mol per decimeter cube hydrochloric acid into boiling tube until it is 1/3 full. The purpose of using zinc granules and hydrochloric acid in this activity is to produce hydrogen gas. Then, close the boiling tube with a rubber stopper that has a 10 cm glass tube and clamp the boiling tube onto the other retort stand. After that, we need to connect the glass tube that contains copper to oxide powder as shown in this figure. After connect it, we have to let the hydrogen gas flow for 10 seconds by allowing the air bubbles to be released in the water before we start the heating process. This process is to remove air in the glass tube. For heating process of the copper to oxide, step 9, we need to use a spirit lamp with a continuous flow of hydrogen gas through the glass tube. When the black color of copper to oxide turns brown completely, we must stop the heating. After that, keep a continuous flow of hydrogen gas until the glass tube is cooled back to room temperature so that we can prevent the oxygen to react with copper again. From that, remove the glass tube that contains brown powder and also eliminate water drops at the end of the glass tube with a cotton bud. And then we shall proceed to weighing the mass of the glass tube together with its contents and record the mass. Repeat the heating, cooling and weighing processes from step 9 to 13 until a constant mass reading is obtained. This is to ensure the combustion process is complete.